Okay, now we feel pretty confident about our goal data set. It's time to derive some insights from the data. So data science best practice is to perform exploratory data analysis before actually using the features in our machine learning models. One of the biggest Databricks Lakehouse advantage is that we can directly query our entire data lake using Databricks SQL. Let me open the DB SQL dashboard and let's take a look. Here's the dashboard built on the gold table that we just created. If you click on this sidebar, you can drill into the underlying queries like this. It feels just like using a SQL workbench. You can write your logic expressed in SQL language freely here. So the Databricks SQL interface really makes your end-to-end architecture highly robust and scalable across different teams in your organization with different type of skill set. After the data visualization, we are pretty certain those features are looking pretty good. We're now ready to move on to the next step, implementing machine learning model to predict the viewability so that we can improve our ad performance and improve the downstream business value. Let's switch to the machine learning notebook. So first few step is, firstly, we load the data set into a Spark data frame from the bits goal table. And we split the training set versus test set. Our target variable is in view specified here. It is a classification problem. The in view column is Boolean. So for the algorithm choice, here we are going to use XGBoost initialize here. It's an instance of XGBoost classifier. Here using Databricks, we can leverage Databricks runtime AutoML capabilities. So HyperOp is something that we've seen data scientists utilize quite often. Here by specifying the Spark trial, just using one line of code, you can distribute the hyperparameter tuning. The tuning job is automatically distributed to find the optimal hyperparameters for the model. Okay. When the hyperop iterates through several hyperparameters, trials are automatically logged in MLflow. The MLflow tracking can help us understand how each set of hyperparameters impact the downstream performance. We can also do quick comparison using MLflow UI before we pick the best one and the best one for production. So actually, as this runs, we can also open the MLflow experiment sidebar, where we can monitor the new MLflow runs for each iteration. It contains a pretty important parameters information, such as, say, learning rate, gamma, the number of estimator, etc., etc. After HyperOpt finding the best set of parameters, we only need to fit the model once, and then use the log model API, which is actually back here, to explicitly log our model as a scikit-learn flavor. And then further, we save our new model to the model registry as a new version. So using MLflow model registry, we can easily name version models and capture each model's stage. So we can push the model into a dev stage, staging, production, or archive. It has a pretty standardized API, so we can directly interface the production job with the registry, automatically test a different version of the model without any code change. So that's That's a good news for operationalize and productionalize your end-to-end machine learning pipeline. So as our final step, step 6, is to predict finally the viewability using the model we just trained. Here is the standardized model path. You specify the model name and the model stage, which now is in production. And then we can load the model as an MLflow Python flavor pointing to this model path. We can later query the result table to filter meaningful signal to see which website and which publisher or device type may likely render fully in-view ads. So to summarize what we went through with this demo, we use Databricks Lakehouse Delta Live Table component to construct pipeline automatically, ingesting and transform nested JSON data. We quickly explore data by directly querying the Delta Lake using Databricks SQL, and we then built XGBoost classifier model managed by MLflow. Finally, we apply the model to predict which combination of the website, publisher, device type to serve the ads so that they are likely to be viewed by our audience.